ladies and gentlemen. This is Mr. Green again, and this is another in a series of lessons for pre-cal. I'm glad you're all here. So let's get started. Where you should be. Well, we are I'm just going to remind you that every 28 days or every week I'm closing things that are 28 days old. So that means you need to get them done, or else you will be getting zeros that will be locked into your grade book, and you don't want to have those locked there permanently. So we want to get those taken care of. What we're taking up is Unit 5. Unit 5 deals with conics. And I want you all just to, if you've read the lesson, you'll notice that the lesson starts by taking two lines. You've got a straight up and down vertical line like this, and then you got some other line at an angle like this. And we're going to rotate this line around the other line. We're going to rotate this line, come on pencil, thank you. We're going to rotate this line around the vertical line. And when we rotate it around, it forms a solid object. Is formed. It forms these two type of cones like this, okay? Or you can call them napes if you want to, but they're cones that look just like that, okay? And then what we're going to do for conics, and you notice it's C-O-N, cones, conics. What we're going to do for conics is we're going to take different planes that intersect these napes or these cones. And we're going to slice and dice these cones, and we're going to talk about the different shapes that they form and the equations that are formed by them. So let's get started. First thing, if you slice it horizontally, you're going to get a circle. If you slice it, and I can go back and look at it, you see right here, we sliced it horizontally like this, parallel to the ground, you would get a circle. An ellipse is formed when you slice it at the angle of the conic here, of the cone, or at any one cone gets sliced at all. And what you'll get is an ellipse. It looks like that. A parabola, well, we've already studied parabolas a little bit. It's when you're slicing just one cone like that, okay? But it's usually at the angle of the cone that you're doing it at. But it could be it'll create a parabola. Now we'll discover there's a different way of doing it, because we will have both horizontal and vertical parabolas. And then there's the hyperbola. A hyperbola is one where you're slicing it vertically and you're getting two objects that are created. Okay? They're just looks like parabolas, but one's up and one's down. So you got two parabolas there. But there is an equation for that one. We're going to start slicing the napes. Okay? The first slice we're going to take will be the horizontal one. It'll be the circle. And so what do we get? The first slice. Well, when we do that, we come up with this general equation for a circle. It says x minus h squared plus y minus k squared equals r squared. Now, what you'll discover as you read through the lessons, h and k are the center of the circle, and r is the radius. Okay, we can deal with that. Okay, h and k are the center, and so the entire first set of lessons that we're talking about circles, we're talking about this equation right here, where you've got h and k and you've got the radius. So it's going to ask you where's the center. It's going to ask you what's the radius. It's going to ask you everything else. I want you to notice h is being subtracted and k is being subtracted. You have to be careful with those because they are subtracted values, and that's just where the center is located. Now, if I went ahead and squared this term out here and squared this term out here, and then I would have some h's that I could combine together and k's that I could combine together to get, because those are just numbers after all. What I wind up with is this general form equation. X squared plus y squared plus ax plus by equals some constant. Okay? So we're going to have some constant number that we've got out there. And what I want you to recognize is that general equation will be the same general equation for every one of these conics. No matter what we do, we get that same general equation there. It's just what different values of some of the parts of that conic, of that general equation, that make a difference. Okay? So this is called standard form for a circle. This one is called the general equation form. Okay? Having said that, we're going to look at ellipses next, and after that we will look at hyperbolas, parabolas, and we'll be done. So, circles are the easiest one. If you have any questions about them, feel free to give me a call. Look for me in Toga. Let's get these questions answered. We're getting close to the end of the semester. We want to make certain we got everything taken care of. So, I will see you next